So this question, we're looking at Edexcel S2, June 2011, question 5. And this is going to be looking at the Poisson distribution and some approximation work using it. So defects occur at random in a plank of wood with a constant rate, that's what tells you it's Poisson, of 0.5 per 10 centimeter length. Jim buys a plank of 100 centimeters. Find the probability that Jim's plank contains at most 3 defects. So first of all, we need to make sure we're dealing with the correct distribution. So doesn't always require this, but it's useful to write down. So let x be the number of defects in 100 centimeters. Okay, so that tells me that I'm dealing with a Poisson, and in this particular case a Poisson 5, because it's 0.5 per 10 centimeters. And I'm asked to work out the probability that x is less than or equal to 3. So this is quite nice, because it can come straight from the table. Okay, so if you look it up in the table, that's going to give you 0.2650. Okay, so you get a method mark for setting it up. So in terms of the Poisson, getting the variable right, the parameter right here, and also using the table correctly to give you your accuracy mark. So Shivani buys 6 planks each of 100 centimeters. Find the probability that fewer than 2 of Shivani's planks contain at most 3. So again, we're buying more than one thing now. So let y be the number of planks containing at most 3 defects. And the reason we're setting it up like this is because this is actually now a binomial again. So y is a binomial where we're doing something 6 times, 6 planks, and the probability of having at most 3 defects is what we just worked out in the first part, so 0.265. And we're asked to work out the probability that fewer than 2 have at most 3 defects. So this is the probability that y is equal to 0 plus the probability that y is equal to 1. So you can see why this is worth a lot of marks now. Okay, so we can't use tables for this because 0.265 isn't in the tables, so we just need to do it a long-winded way. So this is going to be 0.735, so that's the number of failures to the power of 6, plus 6 choose 1, which is 6, times by 5 failures and 1 success. Okay, so it's a normal binomial, nothing particularly nasty about this, and this is going to give me an answer of 0.4987. So answers which round to 0.499 will be acceptable in this particular case. Actually, because of the nature of the question, they would also accept 0.498 if your answer rounds to that, just because of if you've used a calculator and things like that. Okay, so this is worth 5 marks, this part of the question. You get 1 mark for setting it up, and you get an accuracy mark for stating the distribution. So you get a lot of work just by getting the distribution correct. You get a method mark for working out the correct probability. You get an accuracy mark for setting it up correctly with the addition of the 2 sections together, and then a final accuracy mark at the end. So part C, we're now asked to use a suitable approximation to estimate the probability that the total number of defects on Shivani's 6 planks is less than 18. So we're now effectively treating this as 1 plank of wood, which is 600 centimeters long. Okay, and we want the probability that the plank is less than 18. So this is really, if you think about this, if I call it P for plank, P for plank, this is really a Poisson distribution. Okay, and the Poisson distribution that it's going to be is a Poisson 30. Okay, the reason it's Poisson 30 is because we're going to have 5 per 100 centimeters, so that's 30 per 600 centimeters. Okay, now we can clearly see that your lambda is greater than 10 here, so a normal approximation is the best way. So we can approximate P normally 30 root 30 squared. Okay, so you then need to realize again that we've got some issues to deal with. So I want the probability that my plank length is less than 18. So because I'm going from a discrete to a continuous distribution, I need to factor in the continuity correction here. So p is less than 18 is really p is less than or equal to 17.5, and that's where my continuity correction is used. Okay, so standardizing this now, again we've got z is equal to x minus mu on sigma. So x is my 17.5, mu is equal to my 30, sigma is root 30. Okay, that's why I always write it as root 30 squared here to help me do that. And that's going to give me a value of minus 2.28. So it's a negative z value. So that's going to imply to me that probability is less than 0.5. It's the easiest way of thinking about that and making sure it's correct. So we're looking for the probability that z is less than or equal to minus 2.28. And we're going to do this by using our tables. Okay, so if z is equal to 2.28, your probability is 0.9887. So if it's the negative of that, then your probability is going to be the complement. So that's 0.0113. Okay, you could have 0.0112 if it's been done on a graphical calculator as well. Okay, so this is worth 6 marks, so let's look at where they are awarded. So again, you're going to get 2 marks for doing the approximation. So you're going to get a method mark and an accuracy mark for correctly stating that it approximates to a normal distribution. You get a method mark for using the continuity correction and standardizing. So you can see why this is important. So there's your method mark for your continuity correction and a method mark for your standardizing. We then get an accuracy mark for the correct z value. It must be negative in this particular case. And then because it's just looking it up in the table, you get a final accuracy mark here.